Imagine a world where machines predict their own failures before they even happen, saving time, money, and resources. This is not science fiction. It's the reality of predictive maintenance powered by artificial intelligence in the manufacturing sector. Predictive maintenance uses AI algorithms to analyze data from machinery to foresee potential breakdowns. Unlike traditional maintenance, which relies on scheduled checkups or repairs after a failure, predictive maintenance aims to anticipate issues. This proactive approach is made possible through the use of machine learning models that process and interpret vast amounts of data collected from sensors embedded in the equipment. These sensors constantly monitor variables such as temperature, vibration, and pressure, sending real-time data to AI systems that can detect anomalies and patterns that human eyes might miss. For instance, consider a large-scale automotive manufacturing company. It relies on numerous machines to assemble vehicles efficiently. Each piece of machinery is equipped with IoT sensors that gather data on their operational status. The AI system analyzes this data continuously and compares it against historical data to identify any deviations that might indicate wear and tear or an impending malfunction. Suppose a sensor notices an unusual vibration pattern in one of the robotic arms used for welding. The AI system might predict that a joint is about to fail and alert the maintenance team to inspect and address the issue before it disrupts production. In another example, let's look at the aerospace industry, where the stakes are incredibly high. Aircraft manufacturers use AI-driven predictive maintenance to ensure planes remain safe and operational. Sensors on aircraft engines collect data during flights, which is analyzed for signs of potential failures. By interpreting this data, AI can predict when an engine part might need replacing long before it becomes a safety hazard, thus preventing costly delays and ensuring passenger safety. The food processing industry is yet another area benefiting from AI and predictive maintenance. Factories that produce packaged goods rely on a continuous production line. If one machine stops, it can halt the entire process, leading to significant financial losses. By implementing AI systems, these factories can preemptively address machinery issues, ensuring that production runs smoothly and efficiently without unexpected downtime. The impact of AI-driven predictive maintenance is profound, offering more than just cost savings. It enhances operational efficiency, extends the lifespan of equipment, and improves safety standards. However, as with any technology, it's not without its challenges. There are concerns about data privacy and the need for robust cybersecurity measures to protect sensitive information. Moreover, as machines become more autonomous, there's an ongoing debate about the potential reduction in human oversight and the need for skilled workers to manage and interpret AI systems. Looking to the future, the integration of AI and predictive maintenance could transform not only manufacturing, but also other sectors such as healthcare, transportation, and utilities. As AI algorithms become more sophisticated, their ability to predict failures accurately will only improve, leading to an even greater reduction in unplanned downtime and maintenance costs. The collaboration between human expertise and AI-driven insights will be crucial in navigating the complexities of this new era in maintenance. As we continue to embrace these technological advancements, the balance between leveraging AI's predictive power and maintaining human oversight will define the next chapter in industrial innovation.